Hello class, these are the example videos of sketching polynomials with repeated roots. When doing these, let's never forget to keep the previous characteristics we've learned when sketching polynomials. So, with that out of the way, let's go straight into it. You can pause the video and give this a go yourself. If you're comparing it from the previous video, I had to make a slight change for that value here. Anyway, so here we go. To factor this first, two numbers that multiply to 1 add to -2. It's x minus 1 all squared. From here we can see that the x-intercept is at 1 and the y-intercept also is at 1. Combining these two, you can see that the graph should look something like this. There we go, it's 1, 1. And we know this because it has a repeated root at -1. So it's both the x-intercept and the turning point. So for this one, we need to factor it first. We can take x out from each term, leaving us with x squared plus 4x plus 4. We can factor this further as x outside of x plus 2 all squared. So we have an x-intercept at -2 and at 0. We have a repeated root at -2, and since it is a cubic with a positive lead coefficient, it should start here and end here. And remember, we have to factor in this repeated root at -2, so meaning there's a turning point like this at -2. So factoring all of those together, it should look something like see if we can make it as neat as we can. I'm imagining it to be somewhat like this. So that is the sketch that I'm seeing of this cubic. And there we have it. Writing them in, -2 and 0. Now remember, we don't know exactly how low this one is. It could go much lower like this, or even much more shallow like this. We don't know entirely, but we're just getting the general shape of this polynomial. This one here is already factored for us. You can go ahead and try solve this yourself. Now take a look. We have repeated roots at +3 and -1. So +3 is here, -1 is here. And now looking at the total degrees, this is a polynomial of degree 4 in total, and it has a negative lead coefficient. So a cubic looks like this. If it has a negative lead coefficient, it looks like this. But because it is a quartic, it should have, well, actually I've kind of drawn it already for you. It should look something like that. So we know that there are turning points at +3 and -2. So it should look, I'm trying to make it as neat as possible for you here, like this, and like this. And lastly, somewhat like that. Definitely not accurate because it looks rather squished here. It should look more evenly curved. And that there is our quartic at -1, +3. Hopefully you're starting to see this idea of repeated roots, because has a repeated root at 3. It turns and touches the x-intercept at that point. One last one here. Go ahead, try and factor it yourself first. Here I can see we can factor out negative x cubed. This will make this positive x squared. It's become negative x, negative 6x. Let me just check. 4. Yep, so I was just checking. 3 plus the 1 gives us the 4. This will give us negative 9. Factoring this even further, I can think of, sorry, I just realized, because these are both negative, that would make it positive, which means this has to be a positive 9. I made a mistake there. Well, that means we can factor this as x plus 3 all squared. We can already see that this is a quintic with a negative lead coefficient. So going back through the properties of negative degree polynomials, a cubic does this, a negative cubic does this, and since it's also a negative polynomial, it should look something like that. It starts here, ends here. We know, because of this triple, that there's a horizontal point of inflection at 0, and at negative 3 it has a turning point and x-intercept. So doing a quick sketch, I can already imagine the graph looking somewhat like this. It does this, it stops, and it comes back down like that. I can already see that forming, oops, let me try that again. Something like that. So let's sketch that. Let's do this first. Sketching this. Oh, definitely not. Let's try again. Make this a little bit more tall. Oh, I don't know. Let's just do it freehand. And back down. There we go. Definitely not, well, the least accurate of the 4 here, but I think you get the idea of this idea of repeated roots. Hope to see you in the next video. Best of luck.